In this section, we're going to discuss comparison and visualization of differences among groups by drawing Manhattan plot, volcano plot, and heat map. The table of content for this discussion is calculating differential OTUs or ASVs using HR package, displaying differential OTUs, ASVs using volcano plot, differential OTUs or ASVs using heat map, displaying differential OTUs or ASVs using Manhattan plot. HR is the package used for differential expression analysis for numeric gene expression data. The R package HR was published in Bioinformatics in 2010. The author is Mark D. Robinson, and it also most cited article. This article has a great staying power and citation continue to grow. Previously, we already generated OTU type text and metadata text. Experimental data, preferably raw read count, do not need to be standardized. It's also possible to flatten each sample, but it must be an integer. The experimental design includes at least 2 columns. Samples are grouping information. We can have a variety of grouping information such as group, time, location, batch processing, etc. Even using primer and barcodes, we can group information. And what we are studying actually, study the impact of different barcodes on amplification efficiency and the amplification preferences of different primer. As you can see in the OTU type text, in the rows we have OTU IDs, in the column we have samples. And in metadata text, we have information of sample ID, group, date, site, CRA, CRR, barcode sequence, and primer sequence, reverse primer sequence. We can use several methods to generate or plot. We can use command line mode, step by step to calculate and achieve flexible differences analysis and visualization. In the pipeline, in hash 24, we can see our language difference analysis. And this is the script is given there as well. Let's suppose we're going to compare between KO and WT, and then we use input file is OTU type text and metadata text. We adjust threshold of 0.1 and p-value of 0.05 and FDR 0.2. In result, the output will be compare text. We will practice this in our studio later. Let's finish that what we're gonna do. As I told you earlier, there are several methods to draw this volcano plot and heat map, and we can use various methods. This method is used under RMD mode. We can open the compare RMD file, which is already present in the EasyAmplicon, which downloaded from the GitHub under the result directory with the name of compare RMD file. What we're gonna do, we will copy this compare RMD file in our working directory EasyAmplicon, and then we will execute the code one by one to get volcano plot, Manhattan plot, and heat map. Need to generate web pages result for both the result and computational process. And then you can use online server as well to plot volcano plot, Manhattan plot, and heat map. The overall result will be we get by executing the code in both RMD mode and command line mode. We will get KOWT all text, and we will get significantly different OTUs or ASVs after filtering, and we will obtain 3 images like volcano PDF, Manhattan PDF, and heat map PDF. When we get this text comparison result, it look like this. We will have here OTU ID, and then we will get the column of log fold change, log CPM, p-value, FDR, level, phylum, order, genus, mean A and mean B. Log fold change represent the log to transformed fold change, where positive value indicate enrichment and negative value indicate depletion. Log CPM is the log to transformed count per million for all sample, calculated as the average percentage across all sample plus 1 with a range from 0 to 20. Mean A and mean B represent the mean percentage in 2 groups. Level indicate the feature like OTUs or ASVs that have been selected based on p-value and false discovery rate filtering and are significantly upregulated or either downregulated. In order to get the volcano plot, we will run this command in our RStudio, and we will get volcano plot look like this, which shows the big difference in the number and variance of result between this graph and the previous example. As you can see here, the green dot is showing the depleted, and the red is enriched, and the gray color is the non-significant. And by using ggplot, we can draw volcano map code, which is given in RMD document. And this is the detail of how you can adjust if you want to modify this, how you can fix it. Like here, p equal to ggplot, output is x log fold change, y for log CPM, and color is level. Here you can see the detail is given. Set X, Y-axis and color data column is this, and this is for scatter plot, X-axis range and classic theme, and this is scale color manual color control. You can do this, and this is for axis label, and this is for figure title, this is for add significant drop quantity date, and this is for add significant rising quantity tag. If you want to do change, you can do change here. And creating plot with ggplot is like a building with blocks. It requires taking one step at a time, much like drawing picture. Beautiful plots are constructed layer by layer, focusing on the area you want to highlight. You can adjust as what you want. And you can, as I told you earlier, by using this link, you can draw volcano plot online as well. And you can adjust the parameter, like select log fold change, statistical, log CPM, and choose color. And you can modify whether x-axis is symmetrical, legend position, transparency, and point size. Modify the title of the graph to set the title, and modify the size to set the length and width of the picture. And in the heat map, you can see here the heat map is look like this. Here I can show you the example of chronological age of a child of the study from 1 to 24 months, and this is healthy singleton. From training set, this is healthy singleton test set, and this is healthy twins and the triplets. You can see here, this is the heat map. It's showing the OTO IDs here, and this is taxonomic information. And when we run over code, you can get the heat map for intergroup differences, which look like this. And you can generate heat map packet by using RMD code as well. And this is the detail of the code and how you can manipulate this according to your need. You can see here scaling row is always normalized matrix rescreening. You can have all the parameters given here, which you can adjust it. And you can generate heat map online via this link. And by using command line mode, run the script and you will get this heat map. Now Manhattan plot is this. You can draw Manhattan plot the same way we describe about volcano plot, and we describe about a heat map that you can use under command line mode. You can use under RStudio, and you can use online link as well. So similarly for this Manhattan plot, you can do this, because Manhattan plot is essentially a scatter plot used to display a large number of non-zero large scale fluctuations values. It was first used in genome-wide association analysis GWAS studies to display high correlated site. It gets its name from its resemblance to Manhattan skyline. And I can show you here that now you can see when you display an interpretation of the result of the Manhattan map is by using RMD, you can get such kind of visualization, which is highlight the differences among the graphs. Now using RMD, the detail is given here that how you will do this. This is, you can adjust your parameter, and you now already I explained you earlier that how you can arrange all these things according to your preferences. So you have each part corresponding to the picture and can review the previous knowledge helping RM web search. You can do it by yourself and generate Manhattan plot from in the RStudio by running this command. You will get picture like this. Now we can switch from here. We use some C text from the taxonomic level of class. Here we used phylum and display of individual ASVs or genus. You can run this command in RStudio. And if you want to use HR to compare higher classification level aggregate count values, you need to create summary value of kingdom, phylum, class, order, family, genus, and species based on OTO tab text, taxonomy text, and taxonomy summary count RMD. You can see here. And additionally, there are ternary plot, like you can see here. We can draw this as well, and you have to copy the ternary RMD, which is located in the EasyAmplicon master in the result directory under compare. You copy the ternary RMD and bring it in your working directory, and then start running the code one by one. Then eventually you will get this realization. Display the feature unique to and shared between the two groups below with the control group at the top. Now, so far we just discussed all these things that what we can do under the comparison of differences of our groups. So we can use HR, and we will get compare text files and between the groups, and then through that we can draw visualization of volcano plot, heat map, methane, and ternary map. So let's try all of these in RStudio one by one. We can just go back to our RStudio. Now see, this is 24 comparison of differences, which explained in the PPT as well. Now comparison of differences, we can see here, first of all, to perform the comparison of differences, we generate our directory under the result. We will click this code. And now in this script, we will compare KOWT, and we are going to use input file as OTU tab text and metadata text, threshold of 0.1, p-value 0.05, FTR 0.2. Let's run this command. And we can see here in the result. Now see, we generate here compare. Now we generate this text, compare text here, KOWT text, and this is depleted at 16, enriched 23, and not significant 144. And in case if you get any error, it's mean you are not created your directory with the name of compare, because if you have not a directory, then you will not successfully able to get the result. So make sure that you create your directory first. And let's go and see this text which we created just now. Result, compare, and this. As we already explained this in the PPT, let's have a look here and copy this and paste it in an Excel sheet. As I already explained you that in IDs we get ASVs. In the column we have log 2 fold chain, log 2 CPM, p-value, FDR level, mean A, mean B, and this is our samples. And then in order to generate volcano map, we will execute this code. Now see, we have volcano PDF here. In order to get heat map, run this code. You can see here, this is heat map. And in order to get map of methane, to get the differences result, we will run this code. Now here we use some P text. We can switch to some C text as well by executing this code. You can see here, this is KOW2 Manhattan P PDF, P for phylum. And now when we will execute this code, we are using some C text here. Now in order to get the legends, we will execute this line. Now before running this code, I can show you that what is the difference between without legend and with legend. See here, there is no legend here. See this picture, and this is for the phylum. See this picture. Just have a look in heat map. This is the heat map we just obtained via running the code, and this is volcano map. Now when we execute this code, we get here file KOW2 Manhattan C legend PDF. Let's open it. Now you can see the legend here, log 2 CPM, level depleted, enriched, not significant, and the taxonomy. And this is our groups. This is phylum of features. Now next is drawing of individual features. Differential ASVs were sequenced and displayed in descending order by abundance of KO group, and then in order to get top 10 by IDs, we will run this code. Now this gives us top 10 ASVs. Now differential OTUs detailed display by running this code. You can see here, we get here feature box plot ASV2 PDF. Let's have a look. You can see here. If the ID doesn't exist, an error will be reported, right? So Specify a column sort, all descending by mean genus appendance. We will use CSV take and execute this code. You can see here, by running CSV take and all, we will get our some G text. Here we have all the samples, we have genus, we have all these parameters are set, you can see here. And then we will run this code, which will give us compare feature. You can see here feature box plot, Lysobacter PDF. Let's open it. It's compare between the groups. Now for ternary diagram, as I explained you, we have to use our ternary RMD file, and which is already located in our EasyAmplicon master under the result directory. Let's have a look. This is our EasyAmplicon master, which we downloaded from GitHub, and we will see here in the result and under compare folder we have ternary, and this is our RMD file. We will just copy it and paste it in our working directory. We will bring here in compare folder, paste it, and let's have a look. Now it's come here. We will open this. When we open this, the next is ternary diagram, and ternary diagram we can draw by using RMD documentation, which is already present in EasyAmplicon master inside the result directory, which we downloaded from the GitHub. Let's have a look. This is EasyAmplicon master result. We can go to the compare folder. Inside the compare folder we have the ternary folder, and in the ternary folder we have metadata text, OTU versus AVS English text, OTU AVS CIS text, and then we have OTU tab text. So what we're gonna do, we will copy this folder into our own working directory, which is EasyAmplicon, and inside the compare we will place it. And then we come back to the RStudio, and we will see here in result, come here, oops, we will just click ternary and we will open ternary RMD file here. As we open it, we will start running one by one. You can see here, you can run this chunk and then set input and output files and parameter, and then you will run all this by single click. Now you can see here, if we come back to our folder of ternary, we can see here now we generated here ternary ABC PDF. Let's have a look. You can see this is our ternary diagram, and then you get ternary ABCA text, ternary ABCA event, like see, we have all these details, and you can adjust the script according to your own analysis and your own values. You can adjust this, you can modify it, and we get ternary ABC1 diagram as well. You can see here. So this is our differential analysis. So far we performed volcano plot, Manhattan plot, and come back to our terminal. We have plot Manhattan, volcano, heat map, and draw ternary diagram in the differential analysis. Now we can perform the differential analysis under STAMP, and we can generate some input file which we're going to use in the STAMP software. We can generate our input file by running this code. We can see here that we created here the directory with the name of STAMP. We have a look here. You can see here the STAMP, and now inside the STAMP, when we click this code, we created this text file name, text class, text order, text family, text genus, text species, and text OTUO. And then we can use this, we can get this all text file by executing the code under the RMD documentation, which is result format to STAMP, which is also already located in our EasyAmplicon master. Inside the result directory, we can use the same way which we used previously RMD files. Then plot extend column chart and table in order to replace ASVs with genus, we will execute this code. And here we are using input result files are stamp text 5 family text, and metadata result metadata text, and threshold is 0.1, p-value 0.05, ftr none, and width 189, height 159, and the output will be stamp compare. When we execute this code, we will see here, we get here all the groups detail, and then ultimately we have the KOW2 text 5 family PDF. Let's have a look. Stamp, and you can see here this is 90, it shows 95% confidence interval, and this is p-value, its mean proportion, and difference in mean proportion. Come back to the RStudio, and now this file which we generated in under the stamp, we are gonna use stamp software, and we will use this generated file over there and see more realization.